All right, let's jump right in. When we think of origami, we usually picture those beautiful, delicate paper cranes, right? But what if I told you that the very same ancient art form is now helping us explore outer space? Yeah, it's a pretty wild story, from a simple craft to a genuine tool for rocket science.
And that's really the big question we're tackling. How on earth did we get from a piece of paper on a table in Japan to these massive solar panels unfolding in the vacuum of space? The answer is just this incredible story that weaves together spirit, art, and some seriously clever mathematics. You see, to understand where origami is going, you first have to understand where it began, and its origins are way deeper than you might think. They're actually deeply spiritual, rooted in Japanese philosophy long before science ever entered the picture. Now check this out. At the heart of it all is this concept called Aragami. It literally means spirit of the paper. The core belief was that every single sheet held some kind of life force, an essence. So folding it wasn't just a craft, it was this deeply respectful act of honoring that spirit, of transforming a simple material into something meaningful. So this was never just a hobby, it was a true form of meditation. In Shinto and Buddhist traditions, folding paper demanded incredible patience and total mindfulness. Each and every crease was a deliberate action, a symbol of purity and transformation. The whole practice was built on this deep respect for the material itself, almost like a way to connect with something much bigger than yourself. For centuries, origami pretty much stayed in this artistic and spiritual lane. But then, in the 20th century, something amazing happened. Art started to collide with science, and believe me, the world of paper folding was about to be turned completely upside down.
And this revolution was really sparked by two key figures. On one side, you have the artist, Akira Yoshizawa. He's basically the father of modern origami. He created this universal symbol system that took it from a folk craft to a real art form. But on the other side, you've got the scientist, Robert Lang. He was a physicist who looked at these folds and didn't just see art. He saw mathematics. Lang started using algorithms to design these incredibly complex functional shapes, proving that origami had a serious place in the world of engineering.
And that's the crucial part. Pioneers like Lang, they built a bridge between these two worlds that seemed so separate. It turned out the creativity of art and the cold logic of science weren't fighting each other at all. They were just two sides of the same folded piece of paper. And this bridge led to a brand new field. Origami mathematics. Yep, that's a real thing. It's the rigorous scientific study of folding. It uses geometry and computer science to figure out the absolute limits of what a single flat sheet can become without a single rip or stretch. Okay, this is where our story takes its most dramatic turn. Because that new mathematical understanding of folding, it wasn't just some theory stuck in a lab. It was about to solve one of the biggest challenges in modern exploration: how to get really big things into space. So here was the problem for NASA. You need these enormous solar panels to power your satellites, right? And you need huge telescope lenses to see into deep space. But you have to cram all that stuff inside a rocket, which has very limited space. So how do you pack something gigantic into a tiny compartment and then have it unfold perfectly millions of miles from home? And the answer, incredibly, came from a Japanese astrophysicist named Koryo Miura. He developed a specific pattern, now called the Miura fold. It's this brilliant method for collapsing a huge surface into a super compact shape, a shape that can be unfolded with just a single smooth pull. No complicated motors, no parts that can jam, just pure, elegant geometry at work. So how does this actually work? Well, first, a flat surface is scored with a very precise grid of these interconnected parallelograms. Next, this grid allows the whole thing to just collapse on itself, almost flat, into an incredibly dense package. But the real magic is that last step, expansion. With just one gentle pull from opposite corners, the entire structure unfurls smoothly and reliably into its full size. It is so simple, so efficient, it's just genius. And of course, NASA absolutely put this to work. They've used this principle for massive solar arrays on satellites. But the potential here is huge. They're looking at origami engineering for deployable antennas, giant telescope lenses, and even expandable habitats for future missions to the Moon or Mars. It's all about packing more capability into less space. So, when you step back and look at the whole story, what does this incredible journey from a spiritual practice to an engineering marvel really tell us? Well, it's about a lot more than just folding paper.
It's a story of how a single idea can evolve over centuries. It started out as a form of mindfulness, right? A way to connect with the spirit of something simple. Then it became a subject of intense mathematical study. And finally, it became a practical tool, helping us achieve some of our most ambitious dreams, like exploring the cosmos.
And I think that's the real takeaway here. It just goes to show you that a simple sheet of paper, something we all have lying around, holds the potential for both profound spiritual expression and world-changing technology. The solution to a super complex engineering problem was literally hiding in plain sight inside an ancient art form.
And that leaves us with one last, pretty fascinating thought to chew on. If the secret to deploying massive solar arrays in space was found in origami, what other ancient wisdom is out there just waiting for us to rediscover it and apply it to solve the biggest challenges of our time?